study this stuff. What do you notice about the setup back behind me? What have I been doing? Observation, not interpretation. Just what do you notice? Step number one of science. That's the third.
What do you girls see behind them?
Sand. Okay, good. So the lava's going to be flowing onto sand. What else do you notice?
What kind of equipment do we see them set up?
Cameras. Good. Maybe you'll see me doing some measuring. And now I want you to take a close look at this. Different. Hey, that you may or may not have seen already. That's the mouth measure. What if it's measured? On the top we have inches, on the bottom is centimeters. Okay? In science we always use centimeters, the metric system. Always, always, always. Okay? So, okay, step number one, observation. We got sand, cameras. What else do you know?
What do you guys hear? What does it sound like?
Like something rotating. Okay, there's a fan rotating, blowing a lot of air. Good. Okay, you'll see some metal things down here. What do you see on the slope? What? Okay, so we got the rocks here. Lava's gonna. So what happens when we have this huge furnace and hot natural gas nearly right on fire, and that sound you hear is the fan blowing that stuff around. We get even heated. Then that whole furnace inside, there's a crucible. It's like this gigantic bowl. It's got rocks in it. And
Any kind of rocks?
no, this stuff here. We start off with really old, what we call basalt. Old lava rock. We get it from Wisconsin. We take this old basalt rock, we throw it in there, we get it super hot and it melts. And we pour it out. It's lava.
Why Wisconsin?
It's a certain type of basalt that has thermal melting properties that we like to use. We've tried other materials, it's stuff more expensive. Anyway, so we put that stuff in the crucible, we heat it up, then the whole furnace tilts over. Like your teapot's on it's good, right? Okay? The whole thing tilts over, lava comes pouring out, it'll go down that metal trough, and then onto the sand. See, now onto the sand, hard to see, you might see a little gray line right in the middle of the sand. That thing, hang on. Great thing you see on the slope is one of these. We call this a thermocouple. Essentially, it's just a fancy thermometer. This on the very tip, it measures temperature right there. Okay, and then we hook it into a little thing. Anyway, data logger, and then it records temperature.
Is it the little gray line that goes across?
Yes.
Yeah, okay.
Yeah. Right? Right here. Right there. So what is this? What's that thing? Big random metal bar. Scuzz. Has marks on it. That's a measuring device, right? Instead of using my tape measure and melting it, I use something that's metal so it doesn't melt. We tried lots of different things. We tried wood, that was pretty silly. We tried plastic, also pretty silly. Anyway, so that's kind of the setup here. Let me tell you a little bit of the history of the lava project. So this is the Syracuse University Lava Project. It's been operating for about 5 years under Professor Wysocki of the art department. He's a sculpture artist, and under Jeff Carson of the Geology and Earth Science Department. And he's been going for about 5 years. He's done lots and lots of different kinds of experiments. But we're always up for new stuff, which is why I'm here. I'm a PhD student studying rock. So, what questions do you have? Oh, one other thing. What is this? A what? That's a thermal imaging camera. It's an infrared camera. So I can look at it. The screen right here will tell me how hot stuff is. Pretty awesome.
What's the difference? It's like, what's the difference on the camera on the ground and the camera above? Are they the same cameras?
Same exact cameras, measuring from 2 different locations, 2 different viewpoints. Because later I'll go through and measure velocity, which helps us get viscosity and all sorts of stuff. Okay, you ready to see the cool stuff in your whole life? Most people have to go halfway across the world to see this stuff. And not here, we just make it instead. So I'll be right back.
Hey, Mackenzie, do you want to come over here so you can be more centered? Okay. Here? Like, really warm out already? What? Yeah, it's to protect himself. He has to get all nice and hot and then he doesn't burn from the hot lava. What other questions do you girls have? What questions do you want to ask? What's this experiment? I forgot to ask that. Yeah, why is he doing that? I forgot to ask that. Why would you
Chris,
want to do an experiment?
we got a question.
Yeah, we think.
Yeah, you have a question? Yeah.
What's your experiment?
Oh, very good. So specifically what I'm trying to look at is running a series of experiments trying to see how the shape and surface texture of the lava changes with varying degrees of slope angle. So today we're looking at a 10.5-degree slope. And I'm going to compare that with a bunch of other data that I already have. I'm trying to get some more data.
So he's measuring those things on top, right? Folds of those things and how the slope, the temperature as it cools creates those folds. So by knowing what those things are, you can tell a lot by, you can tell a lot about the temperature and the right and the slope and all that stuff. So you can kind of go backwards and look at something like this. Is that right?
Yeah. So the idea is to see something like this in the field and understand how it forms here so that we can look at it out somewhere else in the world and say, oh, well, this formed on this degree slope or going this fast or whatever. That's the objective.
Millions of years ago, this could have poured out like this, but now it's stuff like that, right? Because of the folding of the plates, the tectonics. So
Yeah, rocks move all the time.
Why do you girls think that's important? Why would you want to know that?
actually, they should take that with them because that has the microlights in it too. You can explain that to them afterwards, like why that's important.
Yeah, so why do we want to know that? Why do we want to know what the slope of the volcano is? What? Yeah, so you know how powerful the eruption was after the one?
all within the same exact type, same composition of lava.
Oh, no, you said the flood may lie to do with the volcano thing.
Oh, in a general sense.
Yeah.
Yes.
But that's helpful for not even like looking at a lava, or like a rock, and knowing where it came from. But also, if you know what kinds of volcanoes you have, you might know what the lava will do, and you can predict the time
Yeah.
to sort of produce.
Yeah, so part of this, one of the big main objectives of studying lava, some people go, studying lava, cool, big deal. One of the main objectives is for hazard analysis. There's a lot of people that live near volcanoes that have lava, and so we want to be able to understand what the lava can do when it does come. It's like a train, you just get out of the way. Like, you can't stop it. You have to understand what it's going to do and where it's going to go. That's part of it.
Look at you rotating around this way. And you can get a little closer.
Yeah, come on this way. Come right up in here.
Around this way so you can see. This distance is going to be more or less unlimited.
That's great. Perfect. Yeah. Feel free to get out your phone and send a video to grandma. Whatever.
Get closer. Do you want to come more over here?
Yeah, come closer. Don't worry, you'll know when you're too close. You'll be melting. It's okay.
You girls feel it? How hot do you think it is? 1,000 degrees.
1,000 degrees what? Celsius or Fahrenheit?
Fahrenheit?
Fahrenheit? No, Fahrenheit. Celsius, right up there. Yeah, we're going to put it off there.
What does it sound like? A very hot waterfall.
Coolest thing ever?
So proud, man.
What? If it reached the other sand? Yeah, I wouldn't do anything
So
different.
what do you girls think it would take to make it reach that sand? More lava, maybe? What else? What do you think the slope? Would the slope have to be taller or shorter? What do you think? It's what right now? It's a little bit different.
Yeah.
So how long do you girls think that might take to cool? 2 days?
Okay, good.
Any other thoughts? What are you, Jet? How long do you think it'll take for that to cool completely? A while? A business week?
Business week. Crazy thing is, I'm going to come pull this up later today.
How long
Gonna get
does
some.
it take to get like just
It's really fragile. It's really fragile. And so you pick it up and it breaks into tons of little pieces. It takes me a little while. It's actually kind of orange. I'm picking up all the lava. No, it's not hot enough for long enough.
So what's the temperature that you'll usually get with that thermocouple?
When it's bright orange, it's about 1,000 feet.
So how do you get it off of your metal? Just pull it off?
Yeah, that's the easy stuff. Yeah, the stuff on the sand comes up in a bunch of little pieces. You gotta pick it up and dust the sand off. Takes me a good hour or two. Yeah, we recycle it. So I pick it up, I clean it off, I put it back in there. Good question. So Professor Wysocki, he is a sculptor who likes to do stuff replicating natural landscapes. So he's trying to replicate natural lava. And his overall objective is to make like a parking lot size volcano. We're still getting it. But,
Everything that just came out, like the 2 buckets that you put in?
is it what?
Is everything that just came out like the 2 buckets that you put in?
Oh, that's 2 to 3 buckets.
So, probably a little more than a cubic foot. So,
It does. That's cool.
How hot is the lava
so
actually?
this was a
Can
huge
you guess?
It was about 1170, 1190.
Yeah.
Yeah, that's Celsius.
How hot is that?
How hot is it right now?
So still don't touch it.
Yes. Yeah, in fact, we take water and pour it on. You just make it. Do you at least like it? Maybe it's not the coolest thing ever, but you like it, right? You can come get close, feel the heat if you want. Just don't touch it.
Did your girls feel it when it was coming out? Did you feel a little bit of warmth coming at you? Yeah. Yeah. What shape does it look like? Does it look like any constellations we saw yesterday?
Is there anything you didn't?
Kind of looks like Scorpius.
I mean, the stuff they do.
I want to poke it.
Yeah, we tried stuff that's supposedly melts in the lower temperature. Yeah, we've tried all sorts of